Hi everyone, back again with another video on Kubernetes. Thank you so much for tuning into my channel. I'm Dinuth. If you haven't watched my previous video on CKA and CKAD, I will include the link in the description as well as up here. Go and watch that video if you are really interested to get yourself certified in CKA or CKAD. Those tips that I have included in that video will give you a great advantage when you are taking the exam. Starting from today, I'm going to create a series of videos to get yourself prepared for the CKA and CKAD exams. Today I will start with CKAD, domain number 1, core concepts. Let's get it started. If you have not yet subscribed into my channel, please do hit on the subscribe button as well as the bell sign to get notified when I upload a new video. If you look at the Certified Kubernetes Application Developer Curriculum, you can see the first domain is the core concepts that will give you a 13% weightage in the exam. That will cover the API primitives as well as you need to have the knowledge on how to create and configure basic pods. So let's get started with these subdomains now. A Kubernetes cluster consists of set of worker nodes, call it as nodes. Inside the nodes, we'll deploy the application components as pods. All of these pods, nodes, will be managed by the control plane components. Kubernetes control plane consists of multiple components such as Kube API server. All the functionalities in the Kubernetes cluster will be exposed as an API through the Kube API server. Then there is a etcd. It is a highly available, consistent key value store. All the details about the Kubernetes configurations, all the application component definitions that you are setting up within the cluster will be stored in etcd as key value pairs. The next component would be Kube scheduler. When you ask to create pods in the Kubernetes cluster, Kube scheduler will be picking up these definitions and assigning it into the worker nodes such that pod to be created in this worker node, and that scheduling part will be handled by the Kube scheduler. And also there are multiple controllers available within a Kubernetes cluster to manage the nodes. There's the node manager. To manage the replica sets, there's a replication controller, deployment controller, and many more. All of these controllers will be bundled into a single binary called Kube controller manager that will also be a part of the control plane. Worker nodes also has a set of components inside that. Kubelet is the first component. It will take the pod specifications assigned into that worker node and make sure those pods are running as well as healthy inside the worker node. Kubelet will not maintain any containers created outside the Kubernetes definitions. So only the containers created through Kubernetes definitions will be maintained by Kubelet. And then the next two components inside the worker nodes is kubeproxy as well as the container runtime. Kubeproxy will maintain the network rules on the nodes, and then it will help to implement the Kubernetes service concept inside the cluster. Container runtime is the software that is responsible for running containers inside the worker nodes such as Docker. Further, there are multiple add-ons and then few more additional components. Go through the documentation and the course materials and get to know more details. You need to know how to get the API resource details from kubectl commands. Kubectl API resources command will give you the name, short names, API version, namespace D, and the kind. If you enter -o white flag, additionally you can get the list of verbs as well supported by these API resources. If you want to get the output sorted with the name, or else if you want to get only the namespace bounded components, or else if you want to get API resources only for a API group, even you can do it by putting additional flags into the command. There's another command called kubectl API versions that will give you the list of APIs with its version. That's one way to get the details. Additionally, you can go into the Kubernetes documentation, search for Kubernetes API reference. You can go into that document and find out more details about these different APIs. If you look at here, you can see when it comes to a pod is belongs into core APIs. Core APIs are usually starting with API /v1, and then there are named APIs as well. You can find out all of these details here in this documentation. Rather than using kubectl, you can make all of the configurations using the Kubernetes API as well. You can access the Kubernetes API if you already have the kube-config configured. Kubectl proxy command, you can proxy it into localhost. If you enter curl http proxied URL, you can find out the list of APIs available. Some of them are core API, named API, health related API, and then there are many more. Further, if you specifically want to find out when I want to get the list of pods, what is the API which is getting invoked, you can find out that details by invoking kubectl get pods and enable the verbose mod using -v equals, and then you can provide the verbose level. If you put the verbose level 6 or above, you can find out in the log what is the actual API which is getting invoked while you are making this particular kubectl execution. Namespaces are used to group the resources within Kubernetes cluster. You can select what is the level of grouping that you want. You can create the namespaces based on your environment, dev, QA, UAT, production, likewise, or else if there are multiple applications deployed inside the cluster, you can create the namespace using the application name as well, or else you can concat the application name as well as your environment name and then create multiple namespaces based on that. You can use your own terminology when it comes to the naming convention, what you can use. So to create a namespace, you can use kubectl create namespace and the namespace name. You can use ns instead of namespace, that is the shorter term for the namespaces. You can get the list of namespaces using kubectl get ns or kubectl get namespaces command. To label the namespace, provide kubectl label namespace, the namespace name, and then at the end you can provide the key value pair, let's say app equals demo. If the label is already added, you can add -- override flag to override the existing label. To list the namespaces with its labels, use kubectl get ns -- show labels. When you're using the kubectl get ns command, you will get the output in a tabular format. Into that tabular output, you can add few more columns based on the labels that you have assigned using the -- label columns attribute. Further, if you want to remove an assigned label, you can use kubectl label ns, provide your namespace name and the label name -sign. That will remove that app label from the namespace. Next, you need to know how to connect into multiple Kubernetes clusters. Cluster connections will be happening through a Kube-config file. In the Kube-config file, you will be defining what are the different clusters, the users, and then you will be defining a context based on that. You can check what is the current context, which cluster that you have connected to using a kubectl config current context command. If you want to connect into a different cluster, you can use kubectl config use context and the context name. If you want to set the default namespace for a Kubernetes cluster context that you have in the kube-config, using kubectl config set context, and you can get the current context and then provide the namespace. What's the namespace that you want to use as the default namespace? Within a Kubernetes cluster, containers are not deployed as containers. Containers are wrapped with another level called pods. Within a pod, there can be multiple containers as well. Our pod will share the same storage as well as the networking space. To create the pods, you will be using kubectl run command. You cannot use kubectl run command to create deployments in the latest version of kubectl. Use kubectl run, the pod name -- image, and the image name to create a pod. If you want to create the container in a different namespace, you can use -n and the namespace name. Those options you can add it into the same command. If the container is exposed in some applications on a defined port, you can use ---- port and define the port in the kubectl run command itself. To set the environment variables, you can use ---- and provide what is the environment name and the value for it. While you are creating the pod itself, you can assign labels into that using ---- labels and provide key value pairs separated with the comma. You can run these commands in the dry run mode. It will not create the components in that case. You can add ---- dry run equals client flag. Pod creation definition, you can export it as YAML files using -o YAML flag. You can save that output into a file using this definition as well. And then you can open that using VIO nano editor, and then you can make the changes. After making the changes into the YAML file, you can create these resources using kubectl create -f and the file name. You can do the same using kubectl apply -f and the file name as well. So make sure if the pod is already available in the cluster, you will not be able to create the pod again. You need to delete the pod first. You can use kubectl delete pod and the pod name to delete this pod. You can execute kubectl delete pod and ---- force and the grace period 0 to delete the pod immediately. Additionally, if you want to delete the pod using the labels, you can use the selector option selector, and then you can define what are the label key value pairs. Let's say app equals demo. All the pods with the app demo label will get deleted with this command. Or else if you already have the YAML file and you have the pod definition inside it, you can use kubectl delete -f and the file name. In that case, all the resources that you have defined in that YAML file will get deleted from your Kubernetes cluster. When you're creating the pods, you can pass different commands and the arguments into the container. If you only want to pass the attributes by keeping the default command, you can use ---- and pass the arguments afterwards. If you want to change the default command as well, that is defined in the container image, you can use ---- command ---- you can provide the command and then provide the arguments afterwards. Additionally, there are multiple attributes that you can pass into the kubectl run command. Run command ---- expose will expose the created pod as a service. If you want to change the service account, you can use ---- service account. If you want to set the annotations, you can use ---- annotation option as well in these kubectl run commands. To get the pods, you can use kubectl get pods command. To get the pods in a specific namespace, you can use kubectl get pods -n and define what is the namespace name. If you want to get all the pods in all the namespaces, you can use -A or else ---- all namespaces flag. If you want to know the node name as well as the IP of these pods, you can use kubectl get pods -o wide flag that will print additional details including the node name as well as the IP of this pod. If there is a pod created in the cluster and then you need to get that specification into a YAML file, you can use kubectl get pod and the pod name and -o YAML to get the definition as YAML and then save it into the file. To label a pod, you can use kubectl label pod and the pod name and then define what is the key and then what is the value. If the label is already existing and then you need to change the value, you can use ---- override flag. To view the pod labels when you are getting the list of pods, you can use ---- show labels flag. To print the label values as a table column, you can use show columns. If you want to get pods with specific labels defined, you can use kubectl get pods selector app equals demo2. In that case, all the pods with app demo2 variable is set. Those pods will be listed in the output. ---- selector, the short term is -l. You can use it as well instead of selector. To remove the labels, you can use kubectl label pod, pod name and key of this label with a minus sign that will remove this label. Additionally, if you have multiple pods that you need to remove these labels, you can define all of these pods with spaces, then define what is the label with the minus sign. Label deletion can also be done with the selector attribute -l and define what is the label, and you can remove that flag When you want to create a container which doesn't get restarted, you can put --restart and assign the restart policy into never. In that case, this container will not be restarted. While you are creating the pod, you can connect it into the shell itself by putting -it flag and additional -rm. When you are exiting from this shell, this container will be automatically terminated. When you pass an argument into the same command, rather than connecting into the shell, it will execute the command, print the output, and then terminate the pod. This is an example where when you have an Nginx pod, you need to connect into that pod IP and then check whether the Nginx is up and running. You can get the Nginx pod IP using the first command, and afterwards you can run a busybox container. Into the container, you can pass a wget command with the IP address that will print the output of the Nginx index.html file. To get to know all the details about a pod configuration and the events of this pod, you can use the kubectl describe pod and the pod name command. During the exam, if you are asked to make some additional configurations into the pod, if you don't remember that, you can use kubectl explain command to get the documentation of that section. If you enter kubectl explain pods command, that will print the pods, what are the different attributes that you can pass. If you want to specifically get pod spec container sections documentation, you can get it with kubectl explain pods spec containers. In that case, only that section will get printed. To add or update annotations in a pod, you can use kubectl annotate pod name, and then provide the key value pair of the annotation. If you have multiple pods, you can use other two definitions as well. To remove the annotations, you can use the same methodology that you followed for the labels. If you want to execute a specific commands in a pod with a single container, you can use kubectl exec pod name and --. You can pass the command afterwards. If you want to print the date, if you want to print the environment variable, or else you can put any other commands with the --. flag. If the pod has multiple containers in it, you can pass the container name with the -c as well. If you want to connect into a pro terminal inside a container, you can use kubectl exec. You need to go into the interactive mode with -it and the pod name --sh or --bash, or else bin sh bin bash, and then it will get connected into that particular terminal. If you have some pods with an application running in a specific port, to check this application, you can port forward that application into your local laptop using the port forwarding command. Use kubectl port forward pod name and define what is your local port and what is the pod container port. If you want to change the image of an existing pod which is already available in the cluster, you don't need to delete this pod. You can change it using the kubectl set image pod and the pod name, and then you can define the container name and the image. Once you passed it, it will change the image on the fly. You don't need to delete the pod and then recreate it. Further, you need to master how to use JSON path to filter and specific parameters from output. This is an example of JSON path to print the name as well as the container image from the kubectl get command. Additionally, you can use custom columns as well in this scenario. If you want to print the images, this will print the output in a tabular format. The headers will be name and the image. If you don't want to print the headers, you can use ---- no headers flag as well. That will not print the headers, only print the output that you have defined. You can check the logs of a pod with a single container using kubectl log and the pod name. If you want to tail the logs, you can pass the -f flag, kubectl logs -f and the pod name. When you have multiple containers in a single pod, you need to define what is that container's name using -c and the container name. If the pod is crashed or restarted, if you want to check the logs of the previous instance of this pod, you can check it by passing the -p flag, kubectl logs, the pod name, and -p will print the output of the previous instance of the pod. Right, that's the refresher for the CKAD domain 1 core concepts. I have discussed around 80 plus commands during this video. You should know all of these commands by heart. When a question comes up during the exam, you should be able to execute these commands and then get the task done quickly as possible. I'll post the domain 2 video up here or else in the description. So if you have not yet subscribed into my channel, please do hit on the subscribe button and the bell sign to get notified when I upload a new video. Until the next video, bye for now.